Hi, and welcome to our very first General Chemistry 1 laboratory video. I hope that everybody is home, warm, safe, and sound. Go ahead and grab a cup of coffee, grab a pet to keep you company through your science lab, and we're going to go ahead and get started. Today we're going to be doing our classifying reactions procedure. If you have not had a chance to look through your lab manual and read the background information, go ahead and do that before you watch this video. That way you have an idea of what you are looking for. There are several types of reactions that we are potentially going to be doing today. You are going to have to determine which ones they are. There are two classes of reactions. The first class is redox. The second class is double displacement. In redox reactions, you can have synthesis reactions, you can have decomposition reactions, you can have combustion reactions, and you can have single displacement reactions. That is in the class of redox. So if you say that we have a single displacement, make sure you're also saying that it's a redox reaction. You have to have both of those classifications to get full credit in your post lab. The second class of reactions are double displacement. In double displacement reactions, you can either have an acid-base reaction or you can have a precipitation reaction. Precipitation reactions, you form an actual precipitate. That means that within the solution, your reactants they react together, for lack of better terms, and one of them becomes insoluble in its new form. So it's no longer soluble and it falls out of solution. So that is when you have a precipitate form. When you are looking for that in a chemical equation, that means that you are going to have it be solid on the product side of your reaction. Now, make sure when you are doing your post lab, not only do you have two classifications for each reaction, you are also including states for every single thing that goes in or out of the reaction, and you are including charges. All of this is super easy in equation editor, but if you have any issues at all, please reach out, email your TA. We are here to help you succeed. All right, with that said, let us go ahead and get started. So the very first thing is I am going to do a reaction with magnesium. So here's magnesium. Make sure you're writing down your observations before and after. And I'm just going to add a scoopula full of this into my beaker. Oh no. All right, so I'm just going to add a scoopula full of the magnesium into my test tube, not my beaker. And then I'm going to add hydrochloric acid to it. So I've already pre-measured out my hydrochloric acid, but this is what it looks like before. And I'm going to pour this into my test tube. Now, hopefully y'all can see this, but this is what it looks like. Now I don't know if you can see it on the camera, but we have some bubbles forming at the top. I think it's pretty hard to see in this picture, but we do have some bubbles forming at the top. It is really cloudy right now. So what I'm gonna go ahead and do with this test tube is I am just gonna set it to the side. This is because reactions take a minute to happen, so it's good to give it a few minutes to see if anything else changes. But while we're waiting, I'm gonna go ahead and move on to our next reaction. This one is going to be with 0.1 molar copper sulfate and 0.1 molar sodium hydroxide. So let me set this to the side. In order to run this reaction, I'm going to start out with 10 drops of my copper sulfate. All right. Then I'm going to take my sodium hydroxide and I'm going to add about 2 drops of my sodium hydroxide to the test tube. Okay. So you guys couldn't see from back there because when I put it in, there was a slight color change. It did become slightly darker, but see what else might be happening in here. let me see if I can actually, I'm going to put some regular unreacted copper sulfate in a different test tube so you can just compare what they look like before and after. So this one is my copper sulfate before I added any sodium hydroxide, and this is what it looks like after. Now, for this one, I can see something else happening in here. You guys can't really see it yet. My hope is that it becomes a little bit more clear towards the end of the video. So again, I'm just gonna set this one to the side, and we're gonna come back to it after our next reaction. Okay, so the last reaction we're going to do here in this video is going to be with steel wool and copper sulfate. I know we're missing 2 reactions, don't worry, I'm going to do those in a separate video because they require me to get out the Bunsen burner and I want to get all of these chemicals out because our very first reaction with the hydrochloric acid and the magnesium lets off a pretty flammable gas, so I just don't want to mix any of that stuff together here. We also have to go in the fume hood because of fumes. Alright, so the first thing that we are going to do is we are going to take our steel wool, which looks like this. You don't need a lot of it, just a really small amount. And we are going to put it in a test tube. I'm going to take a glass stir rod. I'm just going to push it to the bottom. The next thing we are going to do is we are going to take our copper sulfate. We need 2 milliliters of that. We know what this looks like. It's the same as before, so I guess you guys can kind of see it better in this test tube. That's our copper sulfate. We've used it in other reactions. And we are just going to pour that into the test tube. All right, so initially, this is what happened. So write down any observations you might have from that. Okay, perfect. Now, one thing you can do to kind of hurry your reaction along is you can stir it with a stir rod. So I'm just going to mix this around a little bit and see if anything gets going. All right. Okay, so it looks like I was able to kind of make the reaction proceed a little bit more. So write down any observations that you see here. Make sure you're looking at the solution as well as any possible color changes you might even be able to see in the steel wool. If I am moving too quickly, leaning forward and coming back, feel free to pause at any point in time. I'm just going to go ahead and set this one to the side as well. All right, well, thank you for hanging with me so far. I am gonna go ahead and stop. We're gonna clean up all this stuff and we are gonna move into a fume hood to do our 2 final reactions that require the Bunsen burner.